Now, this is video I23. And last time we talked about definite integrals, and so let's do some problems with them now. So problem 1, let's say I give you that this is true. So don't forget what we're saying. This is the area under this curve from -1 to 1. We don't need the picture. Okay, let's say I tell you that this is true. Okay, and then think about what this means. It doesn't mean that this entire curve from 1 to 4 is under the x-axis. It just means that more of it is under than over. We could have something like this going on. We have a little bit above, more of it under, and these areas add up to -2. Okay, and then let's say this is also true. We have a different curve. All right, so this is what we're given. And let's see if we can evaluate the following using the properties that we've learned. Okay, and so we see that this one's almost identical to this. We have to remember, though, we need to flip these limits, and if we flip the limits, we change the sign of the integral. And this then is -2, so this answer would be +2. Try it again, and you can always pause the video and try this on your own if you'd like. Let's combine some. Okay, so we're basically going to use these simplifying properties that we had. I'm going to split these up into 2, and I'll pull out the coefficients in each, and I'll try to really practice using proper notation each time. So I have 2 integral from -1 to 1 f of x dx. Notice that this integrand only required the 1 dx, not 1 for each term, but when you split it up, you absolutely have to have the variable of integration each time with each integral. Anytime you have an integral, you want the variable of integration. Okay. And then these we have values for, and so I have 2 times 5 plus 3 times 7, so 31. All right, last one, like this. I would guess that you saw this one coming. So I want to find the area from -1 to 4 of f of x. Okay, we read this as the integral from -1 to 4 of f of x with respect to x. Okay, and I know that I can split this up into its 2 parts from -1 to 1, and note that I'll write that each time, and then from 1 to 4. And then I can just add those together. And so this one I have is 5, this one -2, and so my answer is 3. Okay, so now I'm going to put a completely different problem on here, problem 2, and I want you to pause the video here and try to work it out. Okay, this is going to be the first time I give you the actual integrand here. Okay, and so let's go ahead and try it. The integral from 2 to 6 of x dx. So go ahead and pause the video and think a bit. Think about what you know. Think about what that means. And I'll wait a little bit before I start answering. Okay, so, you know, I kind of hinted earlier that this would be some sort of antiderivative. But that wasn't enough of a hint for us to know what to do with these limits. We'll learn that in the upcoming videos. Okay, but what I do know is what that curve looks like. That's the curve y equals x. And if I graph that, it's that line, very familiar curve. And this tells me find the area from 2 to 6 under that curve. And that looks like a trapezoid. And so all I have to do is find the area of that trapezoid. You could break it up into a triangle and a rectangle, or better yet, just remember that the area of a trapezoid is the average of the bases, and this height here, this base is 2, this base is 6, because it's y equals x. So I take the average of those, and I multiply that by the length of this. We call that the height, that perpendicular distance between the bases, times 4. And so what do I have? I have 8, 4 times 4, or 16. So whatever way you got that, that's great. I'm going to stop this video. I just want to remind you of one thing so you can do some problems. Don't forget the average value of a function is 1 over b minus a, and then the integral from a to b of f of x dx. Okay, so now you should be able to do problems 13 through 20 on the review.